Actually fill out the...
Remind us how to do it first and then go through the slides.
What's your number on the next to the one? 2? So let's say your other number in between the bar was a 5. And this was the number up here. Well, this is lower than 5, so you have minus 5, now you're at 0, right? On the next slide, if your number was 60, this is 98, you'd add 5, now you have 65. Well, but this is lower than 60, so now you subtract 5, now you're back to 60 instead of 65. You guys kind of get it?
Yeah, so now go through all the slides.
So what kind of genetic disorders are there? I mean, are there people who have are born with really short telomeres, or
Yeah,
really wimpy telomerase?
I mean, like if you had any kind of chromosomal disease that affected the DNA, it could affect the telomeres. And specific ones that affect the telomeres, I don't happen to know any of their names off the top of my head. I'm mostly just looking to telomerase and how that could help us in the future. Right now it's helping mice. Well, like a third of the mice, I guess.
See, I've gotten 14.
I'm in the negatives.
Oh, you died. You can't come back.
Oh.
I mean, if you really want to, I don't care. You can
Marina's got a question.
So with this research that they're doing on telomeres, is their goal, are they trying to find like the laser of life to make people?
Yeah, basically, like if you were to Google telomeres, the first thing that pop up would just be like, oh, look at this crazy cream we made that lengthens your telomeres, you know? And everyone's trying to make a quick buck. Now that it's like the first, it's just coming out. Not just coming out. It's actually been around for a while. But, yeah, basically they're trying to eliminate cellular aging, which is what they think is what causes us to age. I mean, because we're made of cells.
So when the cancer cells replicate a bunch, do they also damage their DNA?
Well, I mean, they can get damaged further. It's not if they run out of telomeres, then the replication can damage the DNA. But otherwise, the replication itself isn't going to damage it. But just the fact that it keeps replicating, and you went from one cell with damaged DNA to, you got like a big bundle of cells with damaged DNA. I think most of you know how cancer works, basically.
But for cancer cells that are continuously, keep on dividing and dividing, and don't die, is their DNA getting shorter after?
Yeah, one of the things that's usually going on in cancer cells is that the telomerase gene that got switched off gets switched back on. So it's just constantly adding more on. So as it replicates, it's just usually it would be like, oh, my telomeres are short, I better shut down. But since you got the telomerase always active, and that got activated after your DNA was damaged, you're just continually replicating with this damaged DNA. Yes.
Yay!
And the last slide. Alright, so thumbs up if you're alive.
How do you know you're alive?
You're not at 0.
Oh, what if you're
And thumbs down if you're dead or senescent.
Wait, what number are you guys? Negative 25.
No,
What's the number on your sheet?
4. But it's also where you started.
Yeah,
not
everyone has the same starting point.
Yeah, but there should be certain numbers that are aligned somewhere.
There's, depending, I kind of switched it up. Really, the math doesn't make too much sense with the telomeres because if you have shorter telomeres,
A lot but one.
then if it's under 50, then there's more of a percent chance that you're going to have a number above your number, Because if you're at 40, then there's 60 numbers above you and 40 numbers below you, So if you got 40, you're more likely to go up than down. So that doesn't really make sense. Usually, if you start out with less telomeres, you would go down quicker. But it's an awesome game. It's something to play. Any other questions? Deep, burning questions? Can't live without.
How many people had actually heard about telomerase before? What had you heard?
Well, I just read an article about how shorter
telomeres made you age, so this would actually lead to telomeres. I just read an article about it. That's exciting.
Well, I knew that that's one of the reasons why it's really hard to grow normal cells, like have normal cell lines, is because they stop dividing after,
Like in the laboratory.
yeah, in the laboratory.
That was actually the first article that I read on telomeres that got me kind of interested. My Bio-Expo project was on that. So I started doing it in like the laboratory when they wanted to like continue a strain. They would add the telomerase to like keep the strain alive and not, because they can only keep it through so many replications before the telomeres run out. And then they'd have to start over with a new cell that has fresh telomeres.
And how are they getting the telomerase into the cells? Do you remember?
It's through the epithelium somehow. I believe it's just injections. I was going to put a picture of a scientist holding a mouse with a giant needle, but I thought that was a little...
Over the top?
Anything else? Nothing? You guys don't want to live forever? Alrighty. Well, I hope you enjoyed my presentation, and thank you for listening.
Rachel.